Okay, so the main point of this program is to show important differences between primitive variables and reference variables. And for this, I think it's helpful to use this Java visualizer, and I'll show you that shortly. So a variable can be thought of as a named box in the computer's memory that can store a piece of data. The data that a variable stores is known as the value of the variable. Now, every variable has a type. So some types, some examples are int, double, char, boolean, string, int array. That's a type. It's not int. That's a different type. There's a type int, and then there's another type called int array. String array, that's another type. Scanner, random. These are all different types. Now, there are two categories of types. There are primitive types, and there are only 8 primitive types: byte, short, int, long, float, double, char, boolean. Reference types, that's the other category of types. All other types are reference types. So any other type aside from these 8 is going to be a reference type. So for example, string, scanner, int array, string array, these are all reference types. Now, an important distinction between primitive types and reference types is the following. A variable of a primitive type actually stores the piece of data, for example, the integer that we are interested in. So for example, if I say int x equals 23, so what we have is a primitive variable x. It stores the value 23. It stores it using zeros and ones, but it stores the value of the integer 23. On the other hand, a variable of a reference type stores the address, also known as the reference of an object, but the object itself is not stored in the variable. When we have a variable of a reference type, we say that the variable refers to the object, but it doesn't contain the object, it doesn't store that object. So for example, if I say string s equals 23, so string is a reference type. And here I'm saying that s is a string variable. And so reference variable s stores the address of a string object containing 23. So we have a string object containing 23. S does not store that string object. Rather, it stores the address of that string object. Variables are stored in a part of memory called the stack, also known as the frames. You see here this frames, so we'll come back to that. Objects are stored in the heap part of memory. And often when a variable stores the address of an object, it has the ability to modify the object. Well, let's take a look at this program here. So the yellow line is the line that we're about to do. So we're about to start the program and say int x equals 5. Okay, so let's see what happens when we do that. So we're stepping forward, and here we go. Okay, so we just did line 46. So the line that was just run, that we just ran, was is in gray, and the line that we're about to do is in yellow. So what do we have here? We see in main, we're in the main method on line 47. We're about to do line 47. And so far we have a variable named x. And inside x, inside this variable, we have the value 5. And that's it. So that int x equals 5. Now we're about to create an array containing the elements 1, 2, and 3. So let's go forward. So now we have a variable named array, but it does not store the array itself. Rather, it stores the address of this array object. So this array object lives in the heap of memory. That's where it's found. But this variable array is in the stack, but the variable does not store the array. Rather, it stores the address of the array. And the way we represent this in a diagram or in a picture is by drawing an arrow from this box of this variable to the array object. Okay, so now we can make copies of these variables. So we can make a copy of x, we can make a copy of array. All right, so we can say int y equals x. So we're making a copy. So we have y also has a value of 5. And now we're about to make a copy of array. So we're going to have another variable named array2, and it's going to be a copy of array. So let's see what we have. We see array2 is a copy of array. Notice we did not create a new array. Right? We have only one array object, but now array2 refers to the same object that array refers to. So the key point is, what are we making a copy of, right? So on lines 50 and 51, what are we making a copy of? The answer is we are making a copy of whatever is stored in the variable. But we have to keep in mind, this y is a primitive variable. Sorry, x is a primitive variable, but array is a reference variable. So in the case of x, we're copying whatever is stored in x. What is stored in x? An integer, 5. So in the case of x, we are making a copy of the actual integer. So y gets a copy of that. But in the case of array, right, this variable here, we are making a copy not of the array object, but rather we're making a copy of the address of the array. Because what is actually inside array? What is inside this variable? What's inside this variable is the address of the object. So we are making a copy of the address of the array, but we are not making a copy of the array. So notice there's still only one array. Now let's say we modify y. So if we change y to be 100 instead of 5, will that have any effect on x? Well, let's see. So we're about to do this line 61. Okay, so we see y is 100, x is still 5. Right? So if we modify y, that has no effect on x. How about now if we modify array 2 at index 0 and we set it to be 100? In other words, array 2 at index 0, that's this first element, instead of 1, it should become 100. Will that have an effect on the original variable array? Well, let's see. Well, there's only one array, so this becomes at 100. So now, if we ask what is the first element of this array, that's the original variable, it's going to be 100. Right? So notice what happens when we alter y versus what happens when we alter array 2. So let's actually see that. So if we print out the value of x and y, here we see x is 5, y is 100. So that's what we saw here. And now let's try printing out array and array 2. Okay, let's try printing them out. We get some strange output. Okay, so what's actually happening here is that, we cannot, sometimes, what we wanted to do is print out the elements of the array, right? I wanted to print 100, 2, and 3. But what's happening here is that Java doesn't know that. Java just says, oh, you want to print array. What is array? Array is a reference variable containing, which stores the address of an array object. So the way Java prints that out is as follows: bracket I, that means it's an array of integers. Okay, bracket meaning array, I meaning of integers, at meaning at a certain address. And then here, this is a hexadecimal number. So it doesn't look like a number, but it's a hexadecimal number, a base 16 number. And it tells us the address at which this array is stored. And then when we print out array 2, we also get this address. Notice they have the same address because array and array 2, they both store the same address. They're both storing the address of this single array. Okay, but that's not really what we want. We want to print out the elements of the array. So a way to do that is to say java.util.arrays.toString and send it the array. And that will print out all the elements of the array. Now, actually, we don't need to say java.util.arrays because we can actually import java.util.arrays, and then we, instead of saying java.util.arrays.toString, we can just say arrays.toString. Anyways, doing that, we can print out array and array 2. So let's do that. Okay, so here we see array is 100. It contains 100, 2, and 3, and array 2 also contains 100, 2, and 3. So notice by changing array 2, we are also changing array. Really, we're only changing a single object, right? We're not really changing two objects. We're changing a single object, and these two variables both happen to refer to that same object. So if a change is made to the object, well, then we see that change regardless of which variable we're using. Okay, now we're going to do something a little bit different. We're going to take x and we're going to take array and we're going to send them to the modify method. Okay, so we're about to go to that method. So let's go forward. All right, so now we're at the beginning of the method. Notice here in the frames area, we have main. We still haven't finished working on main. We're going to have to come back to main and do these 3 lines. So we're still keeping track of all the information about main. But for now, at the top of the pile is the modify method. That's what we're working on right now. By the way, the reason this is called frames, really it's a stack. It's a stack containing frames, and each method call is another frame on the stack. So main is one frame, modify is another frame. But they're all really on something called a stack. But that's not really important right now. Okay, so what are we going to do here in the method? Well, this method has two parameters, x and method array. And the arguments that we sent to this method were x and array. So x and array are arguments. And what happens is that their values are copied, and those copies are sent to the formal parameters of the modify method. So the way Java does method invocation involving parameters is that when you send arguments to a method, Java makes copies of whatever is in those parameters, and it sends those copies. It makes copies of whatever is in those arguments. So x is an argument, array is an argument. Java makes a copy of those values and sends them to the parameters of the method. So Java makes a copy of the value stored in x and sends it to this parameter x. Java makes a copy of the value stored in array and sends it to this variable whose name is method array. So they're copies, right? Okay. Now, but the question is, what is being copied? So the same answer as above. So in the case of x, which is a primitive variable, the integer, the actual value that we're interested in, is copied because x stores an integer. So the value of x is an integer. Java makes a copy of that, and it sends that to this method here. So this parameter x is a copy of the original variable x from main. Now, how about array? So Java makes a copy of this variable, of the value in this variable. But what is the value in this variable? The answer is it's not an array object, rather it's the address of an array. And so Java makes a copy of that address and sends it to this parameter here. So this parameter does not refer to a new array object. Rather, it refers to the same array object. It stores the address of the same array object as we had. So notice you see here in the diagram, method array points to the same array object that we were dealing with in main. That array points to, and that array2 points to, method array points to that same array. So what do you think is going to happen if method array modifies the array? Well, that change is going to be reflected in main. So let's see. So if we say x times equals 2, what does this mean, by the way? It's like plus equals, but for multiplication. So it means x equals x times 2. Okay, meaning x should be assigned the value of x times 2. So let's see what happens there. Okay, so we just did that line. Now, notice this value, 10, changed to, this value was originally 5 and it changed to 10. But notice that had no effect on the original value. So we modified the copy, but that has no effect on the original. It's like if you make a copy of a piece of paper and you take the copy and you write something on the copy, you won't see that writing on the original piece of paper, right? So it's a copy. The copy doesn't have an effect on the original. Okay, now let's go for what we're going to do next is go through in a loop, go through the array and double each element of the array. So do method array and xi times equals 2. So let's jump forward here. So we're going through the array and we're doubling each element. Okay, so now it's 200, 4, and 6. And the for loop is done. So notice the array has been modified. Okay, so let's go ahead now and print out the value of x. So here in the modify method, x equals 10. Okay, so that's right, as we saw here. And then we're going to print out the array. Method array is what? 200, 4, and 6. Yes, 200, 4, and 6. Okay, great. Now we're done with the modify method, and we're going to return to main. Okay, so it doesn't return anything. We go back to main. Now we're back in the main method. We print out x. It's going to be 5. And we print out the array. Well, now we have the modified array. The modify method modified the original array. So we're going to print out the modified array. And so the array is 200, 4, and 6. Okay, very good. Now let's just make one little thing. I just want to add one more thing here. Let's say we go ahead and do something like this. Let's say we say int z should be assigned the value of array at index 0. I'm sorry, what did I call it? Yeah, array at index 0. Okay, and then we say z is going to be, let's say, 500. So we can print out, let's print out z. So z is going to be then we want to print out the array. Okay, so let's run through this again. Oops. Oops, I'm sorry. Let's put this in main. I mean, it doesn't really matter that much, but let's put it in main. Visualize execution. Okay, so we're going to run through most. Let's go to the end, jump to the end, go back a few steps. Okay, so this is where we were last time we ran this, and now we're going to go forward. So in z is going to be array index is going to be given the value of array index 0. So z is 200. Now let's say we modify z and we make it 500. Okay, so z is 500. Now does that modify the original array? No, because z is a copy of the element that is in the array. But that element that is in the array is a primitive variable. Well, it's not a variable, it's a primitive value. Okay, so along with primitive variables, there's the idea of primitive values. And this array, the array itself is an object, but the object contains primitive values. And in particular, this first element of the array is an int. It's just a single primitive value. So now z is a copy of that first element of the array. But if you change z, that has no effect on the primitive value that is an element in the array. So anyways, if we print out z, it's 500. If we print out the array, it's the first element is still 200. Okay, keep in mind this last point for the next video.